Okay, so for this lecture, for this lecture, this is our outcome. This is what we want to achieve. I want you to understand, what the conversion of units about, and also we want to talk about significant numbers. Okay, talk about converting units and significant numbers. We need to look at some basic quantities that we need to look at to convert. Length, time, mass, and then area. And also stress. Stress. I think Dr. Samuel already talked about stresses, and strain. Forces can be in concentrated forces, can be distributed forces, or uniformly distributed forces. And then intensity of force. We'll need to look at moments, torque, volume, densities, pressure, and so on. So everything around you, you want to convert temperature from Kelvin to Celsius to Fahrenheit and so on. So there are always two different worlds of units. So it can be from one country to another. It can be from one area to another. It can be one part of the country to another, or between two different generations. For example, and probably two different technologies, or two different history. So we need to convert unit. As a start, let's look at the measurement, from using a microscope up to a telescope, or if you are measuring using a vernier caliper, or you are measuring using the measuring the length using measuring tape, or when you want to measure the weight using sensitive a laboratory weigh, or you want to use a weighing machine that is meant for weighing tons of weight. So that depends on your need. So the reason I show you this slide is to look at the size and or the weight of things, and their component. For example, if you are looking at a very small size, which is the atom, and then up the scale, looking at a virus, and then look at bacteria, and then become larger like ants, mold, and then rats, and then we want to measure ourselves, and then if you want to measure a long animal or a big animal like a whale. So depends on your need. Depends on your need. Accidentally or unknowingly, you know how to choose the correct units, for the one that you need. For example, if you want to measure the weight, the length of a virus, you don't report this in kilometers, isn't it? That is not suitable, because the unit are big. So the suitable unit or the significant unit for virus is, for example, a nanometer, or very small scale animals. And if you want to measure the length of length, what do you think? Usually when you want to measure the length of ants, we can measure that either in millimeter or in inches. And if you want to measure ourselves, our height, usually we report our height as meter, or it can be centimeter. We don't report ourselves in kilometers, isn't it? Or we don't report our height in nanometer. So do this one, this long and large whale usually are measured, the length are measured in meter, or in customary unit in inches or feet, also same with weight, berat. If you want to measure yourself, ourselves, we measure usually we report in kilogram, or in pound. And if you want to measure for whale, they are measured in tons. yeah, in tons. So the right unit for the right purpose, yeah, for the right purpose. You don't simply use anything. So uh, another example is that when you talk about modulus of elasticity, yeah, if you have this subject already, if you talk about the modulus of elasticity of aluminium or metal, usually if you look at the published data, it is reported in gigapascal. Yeah, gigapascal. But if you look at published data for models of elasticity for timber or bamboo, usually they are reported in a kilo pascal, yeah, not gigapascal. So anywhere you go, yeah, anywhere you see, when you read, the right unit is used for its purposes. So this is what you need to understand. This is what you need to ask when we meet online. Another thing about unit is that as a guide for us, yeah, depends on either it depends on how small it is, yeah, how small it is or how large it is, yeah. You need to or usually these are reported in the necessary unit, yeah, necessary unit. Necessary means if you are using the wrong unit, you probably one thing bad about using the wrong unit is that you might end up having to write a lot of numbers. Yeah. So human are the nature of human are they like to shortcut everything. They don't want to make things difficult and difficult to see. Usually, if you are ending up with a lot of numbers or a lot of decimal points, a lot of decimal points, yeah, that it means that you need to change your unit, yeah, from the unit that is full of zeros, for example. You need to have more numbers which is significant. So we're going to talk about that in this meeting. I'm giving you this unit conversion, yeah, this table. I hope that this is useful. We are talking about a metric unit, yeah. This symbol, the symbol of metric unit. Some of it are usually used, and some are not, yeah. But for this class, I think this class we can discuss on this. For this class, usually we are using this unit giga, mega, yeah. We also use kilo, yeah. We use a lot of deci, centi, and milli, yeah, for this class. I'm not, I don't think that in this class we are using other unit. But if you are in the class in biology, yeah, we probably look at more on micro and nano. And if you are studying astronomy, you are looking for a planet that is far, far away. Yeah, probably you are looking at tera or giga, kilometers and so on. So this table should just be probably be a reference to you. I know that you have seen this before. So the reason I show you this slide is because my question is, what if you have a component or material, yeah, or living things that is smaller than micro, nano, and pico? So what is available out there, yeah? This is already small units already, yeah, micro, nano, and pico. But if you have a smaller component or material that is smaller than nano and pico, probably you can use this, yeah. You can use femto, yeah, femto. This is the unit for femto, 2 meter to the unit 10 to the power of minus 15, yeah. And then you can also use yocto, yeah. You can also use angstrom. Angstrom is not metric, yeah, but this is available if you look at anatomy of biological things, yeah, like plants or animals. You can most of them are reported in also angstrom. So this is the unit, 10 to the minus 10. And what if you have a very, very small one? I think this is the last one, plank length. Yeah, plank length is this unit here. So if it is small, probably in the future, you can have this option of unit. Yeah, I'm not sure. I'm not sure in the future they will come up with smaller units. Yeah, I'm not sure, but this is the smallest that I can find. And what if you have if you want to travel from here to another planet, yeah, or another galaxy? You still cannot use kilometer, for example, or feet or miles, yeah, but if you end up with traveling from here to another galaxy, you might want to use a larger unit. Yeah, in this case, I'm showing you here is light year. Yeah, if you astronaut, yeah, if you want to travel from here to another planet, you measure this in light year. Yeah, light year, so that you don't end up with a lot of numbers, which can be confusing. Yeah, let's look at weight and mass. Yeah, okay, mass what is the difference between mass and weight? In bahasa Malaysia, mass is jisim, jisim, and weight is berat. So what is the difference between mass and weight? Yeah, mass is mass is the measure of the object initial property of the amount of that matter, yeah, that it contains. But weight is what is weight? Berat, weight is the object measured exerted on the object by gravity, yeah, due to the gravitational pull. So every time we are looking at weight, yeah, in on Earth, yeah, we need to convert that into Newton. So this is the unit of Newton. Yeah, if you look at this, yeah, 1 Newton is equal to 1 kilogram per meter second. Yeah, and the accelerated the due to gravity on Earth. Yeah, we're talking about Earth right now. We are living here. The gravitational pull of Earth, the numbers is you can use this one, 9.81. 9.81. You don't have to use this longer version of that, 9.80665, yeah, meter per second. You can use this 9.81. So every time we are working with force or weight on Earth here, you need to convert that into Newton. Yeah, so this is the some unit that is used, meter and second. Let's look at example. Yeah, 1 kilogram is about 9.81 meter second. And I'm giving you this 60 kilogram. Let's say 60 kilogram is the average weight of people in Malaysia. Yeah, 60 kilogram. You need to convert this unit when you're looking at force, yeah, or you're looking at stress and so on. You need to convert this unit into Newton. Yeah, so 60 kilogram is to what Newton? Yes, convert this first. You multiply that your mass, yeah, to the gravitational pull. So in Newton, yeah, is about that 588.6 Newton. We already talked about the correct correct unit that you need to use, yeah, for the right reason, yeah, or for the right material. But now we want to look at unit conversion. Why do we need to convert from one unit to another? Yeah, let's see. We have this question: why we need to convert unit? Yeah, have you asked this question? Why do we need to convert unit? Why? Yeah. So let's say you have town A or town B, or it can be country country A or country B. Yeah, it can be person A to person B. It can be generation A to generation B. Yeah, but this is the reason. Let's say town A. Yeah, town A. Both town using sand, pasir for building. as a building material. Let's say town A, it have only these tools, which is pail or bucket. They're the baldi, to scoop sand. They don't have any other equipment or tools, to scoop sand. But town B, they don't have a pail or bucket. They have only cup, cawan, probably a bigger cups to scoop sand. So they end up using a different tool. So end up town A using pail and bucket. Town B are using cups, to scoop sand. So you know that a bucket is larger than a cup. That is our feeling. We know that a bucket usually are larger than a cup. Baldi selalu lagi besar daripada cawan. See, that is not the other way around. Is logic. Everybody knows that. So we need to if town A wants to do business or want to send nak hantar or to send its a bucket of sand to town B, it have to know what is the measurement used in town B. So it says that one pail of sand or one bucket of sand, when they communicated between town A and town B, they found out that one bucket of sand is equal, let's say, they investigate and discuss. When they investigated and when we discussed and when they measured it, they found out that, for example, a pail or a bucket of sand is equal to 10 cups of sand. 10 cups of sand. That is what they know now. After they have communicated and measured, so they found out one pail or one bucket of sand is about, as an example here, 10 cups of sand. So they know the unit conversion right now. The unit conversion is that 10 cups equal to 10 cups of sand equal to one bucket. So when they want to send or do business, or they want to import or export, in terms if there are two countries, if they want to send or if they need 250 cups of sand, so how many pails of sand? Again, if town B needs 250 cups of sand, so how many bucket of sand does town A needs to send? So you know how to do that. So how with this? The answer is about 25 pails of sand or 25 bucket of sand. So what we did here is already we have done a unit conversion. We already change, we only change one unit to another so that town A and town B can communicate. A person A or person B or country A or country B like US and the rest of the world, or between US and Malaysia, you need to be able to change the unit, so that when you want to export your goods or your product, the person the other side, which is USA, understand how much or what is the quantity that they are receiving. This is another table that probably you need to look at. Yes, this is conversion factor between the customer unit. Which one is customer unit? This is customer unit. Pound. Probably you don't need to look at this slug. Inch, feet, and so on. This area. So 1 pound is equal to how many Newton? And 1 inch to how many meter, and so on. So we can you can look at this table when we look at the unit conversion. So I'm showing you again what are the units that you need to convert from one another, like acceleration, energy, intensity of force, moment, power, pressure or stress, modulus, and others. This is the principal unit. What I mean by principal unit is the units that you're going to use most of the time in this class. We're going to look at area, 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 from meter square to inch square to or feet square. When we look at density, we're going to look at kilogram meter cube to slug or to feet a cube. Probably we don't need this. But this in US they still do use that. Force Newton. You want to convert to pound or kilopound. Then you get intensity of force and so on and so forth. You look at this table, and then we're going to look at moment of inertia, moment of force, moment of inertia, stress. This is all the unit used. Pascal, PSI, and section modulus, volume, and so on. Okay, look at this. You know this unit here? Kip. What is kip? In Malaysia, we don't use kips all the time. In US, they use kip. Kip stand for kilopound. So 1 kip or 1 kilopound is equal to 1,000 pound. And you must understand also that 1 Pascal is equal to 1 Newton over meter square. We use this unit PSI. PSI means pound inch square. You can also use KSI. This is in US customer unit. KSI stand for kilopound per square inch. So we unit in this class. Unit bukan unit UNIT. Unit kamu perlukan you all perlukan. You all need to know KSI, PSI, KIPS, and then KPA, GPA, and so on. As a start, why don't you look at this and try this? 20 this area. Going to convert 20 inch square to meter square, and then kilogram to Newton, mass to weight, and then 500 pound into Newton. So I don't think we have any problems. I'm going to proceed this. This is 20 inch square is equal to 0.129 meter square. Try this out. And then next 250 kilogram. 250 kilogram multiplied by the gravity, acceleration of gravity on Earth. So 2452.5 Newton. And then 500 pound is equal to 2224.1 Newton. Next, we like to look at intensity of force. This is intensity of force. The unit of intensity of force is this, pound every inch, or Newton every meter, or a kilopound every feet, or kilopound every inch, or Newton per meter, or Newton per centimeter, or it can be Newton per millimeter, or kilonewton per meter. So this is intensity of force. So let's say we want to call, we have this 250 pound every inch. I want you to convert this into Newton every meter. So my suggestion is that if you want to convert from one unit to another, the best thing is you have to have the feeling. Feeling. You have to have the feeling here. If you don't have the feeling, then, or in other words, if you do not understand this unit here, which is intensity of force, then it is meaningless, to convert it. So the best thing is for you, before you convert, is to know, to understand, to have the feeling of what pound per inch is. And then convert that into Newton per meter, Newton every meter. What I mean by feeling here is that, if I ask you to go to, if I ask you to buy an orange or an apple, I ask you to buy uh, 10 orange, yeah, or 10 durian. Yeah, you have the feeling, you know, one durian or one apple is how heavy it is. You have that feeling, you have that feeling. If I say that, go and buy me one uh, one coconut, yeah, one average coconut, you have that feeling. You can imagine, you can have that feeling of how what is the weight, how heavy it is. If you just weigh with your hand, you probably you can have the feeling of how heavy is one coconut is. Yeah. If I ask you to go and buy a kiwano, for example, yeah, probably you do not know what kiwano is. Yeah, this kiwano probably a fruit that is native to sub-Saharan Africa. So you don't have the feeling. You do not know what is the weight and how it looks like. So that is what I mean by feeling. So when you talk about intensity of force, you need to have that feeling. If you don't have the feeling in pound per inch, uh, the way to do it is to convert into the unit that you understand and know. Yeah, in this case, to Newton per meter over meter. So you must understand what is the meaning of 350 pounds. So I have here an illustration of what I mean or what I understand of this 350 pound every inch. Even I say 350 pound per inch or 350 pound every inch. So this is what 350 pound every inch means. Yeah, if you have a distance of 1 inch, yeah, from this, from here to here is 1 inch. So in the middle, yeah, in the middle of this 1 inch, you apply 350 pounds. So this is what the meaning of 350 pound every inch. So if you have 2 inch, it end up with 700 pound and so on. So that is what is meant by 350 pound per inch. Then you can convert it. Yeah. So how do you do that? You convert first 350 pound to Newton. Yeah. And then after you have done that, you convert 1 inch into meter. That's what you're going to do. So the answer for this is that, yeah, 350 pound multiplied by 4.4482, I convert that into Newton. Yeah, and then I convert this into every inch. I know that one uh, I know that 1 inch, this is a symbol for inch, 2 prime. 1 inch equal to 0.0254 meter. Yeah. So 1 inch is equal to 0.0254 meter. So I end up divide it because inches is smaller than a meter. So what you want to do is you want this to become larger. This number become larger. So you divide that with 0.0254 to make it larger. Yeah, this number. So this is the answer. 61294.1 Newton every meter. Okay, so if you have any question, we discussed it online. This slide is showing you a moment of a force. Yeah, so let's convert moment of a force. But do you know what moment of a force mean? Moment of a force is the definition of moment of force is tendency to cause a body to rotate, yeah, about a specific point or axis. Momentum, this is not moment of a time. This is moment of a force. So let's look at Let's look at one. Convert this 500 pound inch. That's how you say it. Pound dot inch. You don't say 500 pound dot inch. You just read it as 500 pound inch. This can also be a dash. Yeah, can be a dash instead of beside using a dot. You can also use dash. Yeah. So convert pound inch to Newton meter. Doesn't have to be from customary to metric. It can be the other way around. Yeah, but this example is 500 pound inch. Want to convert into Newton meter. Yeah, or Newton. Some textbook. Yeah, some some textbook use dash instead of a dot. Okay, so how do you do this? Again, you must understand what's the meaning of 500 pound inch means. Then you can convert it. Yeah, so I suggest you to understand. Have the feeling of what is 500 pound inch mean. Have that feeling. You must understand that. So I will again like to illustrate what I mean by 500 pound inch. Okay, I define this now. It causes rotation about an axis or a point here. So this is the point. So I'm going to apply 500 pound at the end here. Yeah, at the end here. Let's say the distance or the length of this lever is 1 inch. So this is meaning of 500 pound inch. Actually, this have to go. This because this is positive. It have to go upward here. Yeah, upward. But we're not trying to define the direction. We are trying to convert the unit. So now I understand what 500 pound inch means. So now I'm going to convert it. So I convert this 500 pound into Newton, and then I'm going to convert this into inch into meter. Okay. So this is what I'm doing here is convert this into convert this into Newton, and then because the formula of moment is equal to distance, yeah, multiplied by force time distance. Yeah, force time distance. That's why it's Newton meter. Yeah, force time distance. So I'm going to convert this distance, which is 1 inch, into meter. So 1 inch is equal to 0.0254. Yeah, so this is how you convert 500 pound inch to Newton meter. So end up with this number, 56.49 Newton meter. Okay. Next, I want to convert pressure or stress. Yeah, stress can be a compression stress, can be tensile stress, can be bending stress, can be torsional stress, and so on. Yeah, and this unit is also for pressure in terms of an area. Yeah, not in terms of cube. Okay, so again, you must understand what's the meaning of this number and unit here. Yeah, for 640 pound inch, convert that into Newton meter. Yeah, Newton meter, or in another word, this can be 640 pound. Yeah, per inch squared is this unit P S I, pound inch squared. I want to convert into this. This unit is actually unit of Pascal. Yeah, so in other words, I want to convert 640 pound inch squared PSI into how many Pascal or Newton per meter square. So again, you must understand the meaning of pound per inch square. Let's understand the meaning of this 640 pound inch square, yeah, or PSI. Have an illustration for this. So let's say if you have an area, yeah, let's say this is on the floor. Yeah, the area is 1 inch over 1 inch, not over 1 inch per multiplied by 1 inch. This area is 1 by 1, yeah, 1 by 1. So at the center here, at the center of this square or this area here, at the very center, yeah, center or centroid or center point. If you can see where I put here, this is the center point of this area, square area. We apply, this is 1 by 1. At the center there, 640 pounds. So this is the meaning of 640 pound every square inch. So after I understand that, yeah, I can convert now pound into Newton, and then I'm going to convert inch square into meter square. Yes, so this is the answer. Okay, what I did here, what I'm doing here is convert pound into Newton again, and then I'm going to divide this with 0.0254 square. Please remember, if you have this square area, yeah, don't forget to square this one. So this is the answer. I'm not multiplying this with 0.0254 because 1 inch is smaller than 1 meter square. So the answer is 441. Yeah? Sorry, 4412623.23 Newton. So this is the answer. Okay, talking about the significant unit that, or the necessary unit that you want to use, yeah. So because there's too many numbers here, isn't it? Remember I told you when there's too many numbers, it's an indication that you probably need, or it's necessary to change to another unit which is more suitable. So for instance, this one, if I just convert this into kilonewton, then instead of having a lot of number, I end up with, or if I change this into kilo Newton over meter square, yeah, so I end up with what I do is 1, 2, 3. So less number. So the number now is only 4, let's say 13, 4413 kilonewton per meter square. So this is a better unit because it reduces the usage of number with the same meaning. Yeah. So this is more necessary, more significant, yeah, for this situation. And if you have this unit, probably is a good idea. It's a good idea to have some decimal point. Let's say 4, yeah, 4, 1, 2.6, yeah. So this is quite significant. This number is a significant number. But this probably if you are using Newton over meter square, yeah, this one, probably you don't need so many decimal numbers. Yeah, probably you don't need any decimal numbers here. Not very meaningful. Yeah. So let's discuss on this significant numbers when we meet online. This is an example or exercise. You can try it first, and then we can discuss this when we meet online. Yeah. So 7900 in English, or in English you can read this as 7900. Yeah, 7900. But in bahasa Malaysia you can say 7900, no 7,900. We don't say that, but in English, we can say that 7,900 is quite common. People will say this. So convert 7,900 Pascal, this Pascal into PSI. Convert this 250 Newton every millimeter to kips per every feet, and then 500 Newton meter to pound feet. Try it out. We can discuss this when we meet online. This is the unit we use when we report metal, aluminium, or much stiffer material compared to timber, bamboo, or rattan, or some biological material for construction purposes. So this is the unit that if you look at many textbooks on strength of material, or durable, deformable bodies of material, metal, aluminium, steel, and so on, is reported as gigapascal. And then convert this into KSI. I'll already talk about. If you refer to the previous slide, you should know what KSI mean. In US, same level here. When metal, the stiffness of or modulus of elasticity of metal, aluminium, if you are using the customary unit, it is reported as KSI. In metric, it's reported as gigapascal. Try this out. Here's another 3 exercise that you can try. Please try this first before we meet. This is the technical numbers. You take a look at this slide, and then we can discuss this online. And there's some question that I post here. Probably can answer this before we meet. So that's it. We can continue this when we meet. Thank you very much. Assalamualaikum.